Alright guys, so now we know all about real numbers, about their properties, we know how to evaluate an expression, we know how to simplify an expression, so finally it's time to solve an actual equation. Alright, this is what algebra is all about. We're going to be solving many different types of equations. These you should be pretty familiar with. These are linear equations. Some will be just one step, could have multiple steps, could involve some of the properties. Alright, we're going to kind of investigate all types today. All right, so this first equation, we can do it in two steps, but really this is meant to be a one-step equation. We've got this negative 5/8 being multiplied by x, and it's equal to 20. So our goal is to get x by itself, so we need to get rid of this negative 5/8. All right, so here's the two-step way. I would start by eliminating the fraction, and you cancel out a fraction by multiplying by its denominator. So I'm going to multiply by 8 on both sides. Alright, the 8's will cancel. That leaves me with negative 5x equals 160. And then you're going to divide by negative 5 on both sides. So x equals, let's see, that's 32, negative 32. Alright, so two steps, not too bad there. But like I said, this is kind of meant to be a one-step equation, so I want to show you that just in case you like it better. Anytime you have a fraction in front of your x like that, all you have to do is multiply it by its reciprocal. Remember yesterday we talked about inverses. The multiplicative inverse is the reciprocal, so you flip it over, and if we multiply these two numbers together, they cancel each other out and they equal 1. And that's what we want. We want it to be 1x. Alright, so if we do that to both sides, times negative 8/5, alright, the negatives cancel, the 8's cancel, and the 5's cancel. That leaves us with just x. Alright, now this calculation is a little tougher to do, but you'll notice it's the same exact thing we did over here. We're multiplying by 8, 20 times negative 8, and then we're dividing it by 5, divided by 5. Okay, so you could do it in two steps in your head like that, or you can pull up your calculator and type it in. Let's do 20 times negative 8. And notice if you hit Control divided by on this calculator, it'll make it an actual fraction, just so it looks a little more like what you wrote on your paper. You don't have to do that. You can just hit regular divide and it'll do the same thing. And there's our answer of negative 32. All right, y'all give this one over here a try, and then unpause the video and come back and see if you got it right. All right, so if we use the one-step method, we're going to multiply this by 3 halves. Negative 18 times 3 halves. Alright, so those will cancel, leaving us with y. Alright, remember, you can kind of do this in two steps. Sometimes I like to divide first. 18 divided by 2, well, that's 9. So I'm going to just cross that out and make that a 9. So it's negative 9 times 3. Well, I know what that is, negative 27. Alright, so if you get on a test where you don't have a calculator and you have to do a little calculation like that, just do it in two steps in your head. Okay, and then you can come up with those. Break it down into pieces that you know how to do. All right, like dividing 18 by 2, you know how to do that. Multiplying 9 times 3, you know that. All right, even though multiplying 18 times 3 halves isn't something you just automatically know. All right, let's try a couple that have some multiple steps involved. This is also going to use some of the properties that we talked about in our last lesson. Okay, so we've got 5 times x plus 3. Okay, so remember the distributive property. If we have a number outside the parentheses, we can distribute it and multiply it to both those things. All right, I have a 2 outside this one as well, so I'm going to multiply the 2 by those two, distribute. So that's going to be 5x plus 15 plus 2 minus 2x equals 14. All right, combine like terms, so I'm going to combine the 5x and the negative 2x. Remember, this is really the commutative property, allowing us to rewrite these in any order we want and then add them together. So 5x minus 2x, that's 3x, and then I've got a 15 and a 2. Add those together, you get 17. All right, now we need to get x by itself. So I need to start with the 17 over here. We're going to move that to the other side, or we're going to cancel it from here. And whatever you do to one side of the equation, you have to do to the other side. So that's going to leave me with 3x. 14 minus 17 is negative 3. And then we divide by 3. Divide by 3. And that leaves me with x equals negative 1. All right, the dividing by 3 is the inverse property that we learned about. We only did addition and multiplication, but remember, dividing by 3 is the same thing as multiplying by a third. It's just like multiplying by a third. So that's what we're doing here, is using that inverse property. All right, give the next one a try on your own, and then unpause the video and see how you did. All right, so we got one thing to distribute here. Leave this negative 10x alone for the moment. 3 times 4 is 12x minus 6 equals 6. All right, negative 10 plus 12 is 2x minus 6 equals 6. Okay, if we add 6 to both sides, we get 2x equals 12. And then we'll divide by 2. X equals 6. All right, so one more thing that this section does is it has you solve an equation, and then that's not going to be the answer. You're going to have to plug it back in. This is a big thing on like standardized tests. So the SAT, the ACT, STAR exams that you may have to take, a lot of the problems have you plug something back in. It's like a one more step of thinking for you. Okay, but I'm going to show you a little trick on these. So I'm going to show you the traditional way, and then I'll show you a little trick that can kind of make the work a lot easier. So normally they give us this equation, and we'd solve it. So let's rewrite this down here. All right, so we'd add 12 to both sides, and we get 6x equals 30. Then we divide by 6, and we get x equals 5. And then we'd plug 5 back in, we'd evaluate, and we get 30 plus 5 is 35. All right, so here's your little trick that can kind of make this a little easier. We have 6x minus 12 equals 18. Okay, well, they want us to know 6x plus 5 equals something. So what would I have to do? Notice how the 6x's are the same. Now this little trick doesn't work unless the 6x's are the same. So if this was 5x plus 5, we'd only be able to do it the traditional way like we just did over here. But since they are both 6x's, what can I do here? How do I get from negative 12 to positive 5? All right, what number would I have to add to negative 12 to make it equal positive 5? Okay, well, if you think about that, if I add 12, that would make it 0, and then add 5 more, that would make it at 5. So 12 plus 5 is 17. So if you add 17 to both sides, this becomes 6x plus 5. 18 plus 17 is 35. And that turns that 1, 2, 3, 4-step problem into a 1-step problem. All right, now you may hate that and you don't understand it, and that's fine. The traditional way, it doesn't take that long once you start writing it out yourself and you're not talking it out like I am, and that's fine. So I really don't care. As long as your work justifies your answer, it doesn't matter to me what method you use. Okay, so you could even come up with some other crazy way that I haven't even thought of yet. And as long as it mathematically makes sense, I'm good with that. Okay, that's why it's important to show me what you're doing, though. If you just have a single answer there, and I don't know how you got there, it's going to be tough to see where your thinking is. I want to see what you're thinking. That's why I like seeing the work. All right, so y'all can give this one a try. Use either method that you want. Unpause the video, see how you did. All right, so this one got a fraction in there, so that's kind of crazy. Let's do the traditional way first. Almost wrote a plus sign. Let's go back. All right, so we're going to subtract 2 to cancel that out. So minus 2, 5y. All right, now you can obviously use a calculator here, but just in case a calculator is not available or whatever, how do we convert this into a fraction? We need a common denominator. So right now it's 2 over 1, so I need it to be a 3. So I'm going to multiply this by 3 over 3. You have to do the top and the bottom. All right, so that's going to make this a minus 6 over 3. 8, and you only subtract the numerators. 8 minus 6 is 2/3. All right, and then we're going to divide by 5 to cancel that out. Writing a divided by 5 is going to look weird. Remember we talked about inverses? Dividing by 5 is the same as multiplying by a fifth. All right, if you remember multiplying fractions, you go straight across. So that's 2 over 15. All right, now remember, we're not done yet. Once we get to this point, we have to plug our 2/15 back in to 5y minus 6 to figure out our answer. So it's 5 times 2/15 minus 6. So I'm going to divide 5 over 15. The 5 cancels and 15 becomes a 3. If we reduce 5 over 15, that's 1 over 3. All right, and then the 2 stays on top. So it's going to be 2/3 minus 6. I know I'm going to need a common denominator to make this happen. So I'm going to multiply this by 3 over 3. So that's going to be negative 18 over 3, which equals negative 16/3. And that would be our answer on this one. All right, so you can see with all these fractions, that method gets a little bit lengthy and there's a lot of little places to make mistakes. All right, so if you try the faster method, I'm going to section this off some space here. All right, so we've got 5y plus 2 equals 8/3. And I want to know what 5y minus 6 equals. I need to subtract 8. 2 minus 8 equals negative 6. So subtract 8. All right, so I still have to do a little fraction stuff here, but this is 8 over 1. So multiply that by 3 over 3, and you get negative 24 over 3. And 8 minus 24 is negative 16 over 3. And there's your answer in one fairly harmless step. All right, a lot less chances to make a mistake if you go that route instead of the other.